Alright, let's look at this and let's look at complex numbers. By the end of this, I hope that you will understand the concept of a complex number and be able to form some simple operations with complex numbers. Okay, so let's start off though. Before we can actually look at complex numbers, we need to look at what's called an imaginary number. So what is an imaginary number? You know, it's not numbers I just make up. That doesn't work. So, an imaginary number is we use the symbol a lowercase I. And it's caused by the square root of a negative 1. Because think about it. If you have the square root of a negative number, there is no number times itself that will give you a negative. Because two negatives multiply and give you a positive, two positives multiply. So any number times itself will always give you a positive answer. So to have a square root of a negative number, such as negative 9, before you would have just said there's no real answer. Because there is no real answer. It's an imaginary answer. So we split this up and say the square root of 9 and the square root of negative 1. Well, the square root of 9 is 3. And now we say the square root of negative 1 is I. So the square root of negative 9 is 3i. Wow, sir, that's kind of interesting, is it now? Anyways, okay, so let's look at the square root of negative 27. Now, I'm not saying you have to do it like this, but I would probably highly recommend doing something like this. So I like to split this up. Negative 1, so automatically when I see negative, write a negative 1. Then I'm looking at 27. Well, the biggest perfect square that will divide into 27 is 9, and 27 divided by 9 is 3. So the square root of negative 1 is I, the square root of 9 is 3, and then the square root of 3 is left over, so it stays under the square root symbol. So kind of doing like what we did before, where we kind of split these up like this, and you could say the square root of the 9 was 3, this was the I, and the one at the end should be the one that stays under the square root symbol. That's a very interesting question. Alright, let's look at the square root of 18. Again, negative 1, and 18 would be 9 and 2. Again, trying to find that perfect square that can divide into 18. So, now I split them up. Again, this number here at the end should just be on the end, like square root of negative 2. So, what's the square root of 9? It's 3. What's the square root of negative 1? It's I. What's the square root of 2? It's just the square root of 2. See? Kind of like how that works. Now, keep in mind that if we put, and I'm just letting this play out, I is equal to the square root of 1. So when you do I squared, you end up getting negative 1. Because the square and the square root cancel each other out. I to the third would be negative I. Because I to the third would be I squared times I. And I squared is already negative 1. So negative 1 times I would be negative I. And then I to the fourth would be 1, because negative 1 times negative 1, which is I squared times I squared, is 1. Now, that pattern follows through. I to the fifth would be negative square root of negative 1, I squared, or just I. I mean, I should put that as a negative 1. I don't know why I didn't before. And I could say that's just I. Or, and you can kind of see I to the 6th would be negative 1, I to the 7th would be negative I, and I to the 4th would be 1. So kind of see that keeps repeating. So I could say, what's I to the 25th? Oh, that's divided by 4, and you get like remainder of 1, so it's just I. Okay, something like that. Anyways, because every 4 equals 1. Let's look at multiplying. All right? So I'm multiplying imaginary numbers. It's going to get there. Okay, so what's negative 5 times 3? Negative 5i times 3i. Well, negative 5 times 3 is negative 15. I times I, anything times itself, is that thing squared. So I squared. Am I done? No. Because I squared, we now know, is equal to negative 1. So I'm saying negative 15 times negative 1, which is positive 15. So your final answer is 15. Well, what about 3i times 4i, sir? Well, that's 12i squared. And, well, I squared we now know is negative 1, so negative 1 times 12 would be negative 12. Boom. Yeah. All right. Next one. Let's try this. Uh-oh. What have we here? You are trying to trick us, sir. No, I'm not. Look, what you do on this type of problem, and here's the big thing. You don't, like, say, multiply those two numbers first, like the way you did maybe hopefully in the previous assignment. Excuse me. you have to take this and take out the i's first. So take out the negatives first. So now I'm saying I times the square root of 6 times I square root of 15. Now I times I will give me I squared. Square root of 6 times the square root of 15. Now I can multiply these two numbers and get 90. Okay, we now know I squared is -1, but now can I simplify the 90? Yes, I can. That's the biggest perfect square that will go into 90 is 9 with a remainder of 10. Or I'm sorry, 9 will go into 90 10 times. I shouldn't say remainder. Okay, so what's the square root of 9? 3. So, and then the I squared is a negative, so automatically I put the negative. Square root of 9 is 3. Square root of 10. So my final answer would be -3 square root of 10. Okay, let's do one more example with that. So again, take out the I first, take out the negative, put I. You got to do that first. Do you understand? Do that first. Okay, so that gives me I squared. 20 times 12 is 240. Now the largest number that goes into that, I believe, is 16, and 16 will go into it 15 times. So I have I squared times the square root of 16 times the square root of 15. And the square root of 16 is 4, and I squared is equal to -1. So then that means that's -4. And then I still have the square root of 15. So you kind of see there how that square root of 15 just stayed there in the front. Alright, now I'm ready to show you the complex numbers. What is a complex number? A complex number, first off, let me tell you this. These, like 6i, -2i, I squared of 3, those are called pure imaginary numbers because all they have is imaginary numbers. A complex number is like combining a real number with a complex with an imaginary number. And we always write it in the format of a plus bi. A is the real number and bi is the imaginary number. So if I write something like and that's considered a complex number. So if I write something such as 3 plus 2i, that's considered a complex number, where 3 is the a, the real number, and 2i is the imaginary number. So when you have a complex number, you're combining a real number and an imaginary number. So to put this in kind of perspective, you saw, or you grew, or you've known for as long as possible how to deal with real numbers. Everything that you've done before was with real numbers. So you had your positive numbers, your fractions, your negatives, your decimals, whatever. Those are all real numbers. Even square roots, like square root of 3, square root of 4, decimal numbers like that, those are still considered real numbers. Now I've introduced imaginary numbers, where you have numbers with a letter I. That means that number times the square root of -1. That's really what that comes down to. When I say 2i, I'm saying 2 times the square root of -1. Okay, so when we want to do, if I wanted to write a real number as a complex number, let's say just the number 5, then that's 5 plus 0i. Now, this real number, just like the way you could say write 5, but make it into a fraction and make it a rational number, like by saying 5 over 1. Same idea here. I'm going to rewrite 5 as a complex number. And then, here, we want to do, like I could do imaginary number like 6i, and that would be as a complex number 0 plus 6i, because that would be with no real number. Now if I put those two together, 5 plus 6i, I have a complex number. Okay, so there's that. Now how do you add or subtract complex numbers? It's as easy as combining like terms. Okay, this is our last little bit to this. I'm only going to do 2 examples. So if you have something like this, 5 minus 7i plus 2 plus 4i, well, just put them under each other and line them up. 5 plus 2 is 7. Negative 7 plus 4 is negative 3. And you're done. It's 7 minus 3i. If I was subtracting, just like you did on the previous test, you got to change the signs. So as I'm changing it, the positive 3 would become negative 3, and the minus 6 would become plus 6i, and then I could combine them. 4 minus 3 is 1, negative 8 plus 6 is negative 2i. And that's it. So we will have an assignment on this, but hopefully this was a little bit informative for you and got you a little bit more understanding. Thank you so much for your time. Take care.